Hi, how are you doing? Enjoying my virtual classes? It's a great, you see, it is a, what do you call that, a blessing in disguise. So we are enjoying the blessing in disguise and enjoying these virtual classes. Not as good as the real classes, but even then, we have to do something. So, in continuation with my lectures on applied toxicology, and after discussing the last lecture, wildlife toxicology, we now move forward and we shall be discussing something very serious, and that deals with the chemical warfare agents. War is dangerous, and then chemical war is again more dangerous. So there had been many wars since, you see, since the beginning of civilization, we can say that. But our memory goes to World War One and World War Two. We do not know what happened before World War One. There were wars before that also, but generally our memory goes to the World War One and World War Two. And when we talk of these wars, we find that these wars are using, or the warriors are using chemicals, they are using nuclear devices, they are using biological warfare agents, and they are using radiological devices. There are four categories of the warfare agents. One is biological, second one is chemical, third one is nuclear, and fourth one is the radiological. We are not going to talk on biological warfare agents, but we are going to talk on chemical warfare agents, chemistry, how the chemistry entered into this this business of wars. This is a time scale that I would like to discuss with you. Actually, in the beginning, we had only three war chemicals. One was chlorine, another one was phosgene, and the another one was the nerve gases. These nerve gases are the kings of poisons. As I was discussing with you, the arsenic is a poison of kings, and arsenic is a uh, the king of poisons. So nerve gases are the kings of poisons, chemical poisons. Let us begin with the brief history of these chemical warfare agents. And as far as available literature takes us, it takes us to 1675. In 1675, there was a war between France and Germany, and they were using these war chemicals, and the France and Germany, they signed a pact not to use war chemicals in Strasbourg in 1675. Then we came down to another incident of 1845, when the French troops smoked. They use the gas, smoke gas, and they smoked a local tribe which was called as the Berber tribe. Then we come down to the World War was there between 1914 to 18, and in 1925, I have discussed you at that time there was no United Nations, but at that time we had a League of Nations. So in 1925, in Geneva, a treaty was signed by different countries using these war chemicals, and that treaty is called as Geneva Protocol. You must remember what Geneva Protocol is. You must remember what Strasbourg Agreement is. The Geneva Protocol was signed by League of Nations to stop the chemical and biological warfare agents. That no country will be using either the chemical or the biological warfare agents. And then in 1935, there is a record that Mussolini was a great warrior. Mussolini applied mustard gas to empower in the form of bombs. Where? Ethiopia. Mussolini used warfare chemicals in the form of bombs to conquer Ethiopia. At that time, Haile Selassie was the king. He was a great dictator, Haile Selassie, and Mussolini wanted to conquer Ethiopia, and he used these bombs. Then in 1936, Taboon came into existence. I will be discussing with you the different chemicals, serine, taboon, soman, phosgene, and there are different chemicals. We shall be discussing each one in details. But at that time it was taboon. In 1936, serine was used against the British. And then in 1953, this soman came into existence. So this is just after the World War One, how these chemicals were being used. But the Geneva Convention did not stop the countries using these war chemicals. We have the example of Vietnam War. In Vietnam War, America used the Agent Orange. It is a dioxin. Agent Orange again Vietnamese. It is also a defoliant. How it was working? It was being sprayed by the jets of American army, and they were defoliating all the trees and plants, and as a result the hiding troops of Vietnam were conspicuous, and then they were bombing them. It was Agent Orange. So we talked about chlorine, we talked about phosgene, we talked about mustard gas, we talked about serine, we talked about taboon, we talked about soman. Now it is Agent Orange. Agent Orange was used in Vietnam War between 1961 to 71. Then between 1963 to 67, there was war between Egypt and Yemen. Yemen is still, you see, is a devastated country, a poor people. They are dying because of malnourishment. They are dying because of lack of resources. They are dying because of an international political failure. We are not going to discuss that. We are to summarize that the nerve agent was used against the Yemenis people by Egyptians between in 1963 and 67. It's not far back. In 1972, the Biological and Toxin Weapon Convention was organized, and there are different countries. They gathered together to combat, to restrict the use of the biological and chemical warfare agents, as the Geneva Convention almost failed. Then in 1980, there was a war between Iran and Iraq, and they used Iran war used taboon. Taboon is a gas. Then in 2013, just you see, few years back, in 7 years back, uh, Syria used these war chemicals, and the Syria used was serine against its own people. It's a tragic. The Syria government was using to kill its own people by using a gas, and that gas was a serine. And in this way, you find that these soman, serine, taboon, they have been used by at one time or the other by the countries. And the real person, you might have you must remember the Haber's rule when we talk of Friedrich Haber. Friedrich Haber was the chemical advisor of the great warrior Hitler. And Friedrich Haber was awarded Nobel Prize for nitrogen fixation. Friedrich Haber worked on the synthesis of ammonia, and the ammonia then was used as a fertilizer, and it revolutionized And Friedrich Haber was also awarded a Nobel Prize for the discovery on nitrogen fixation and for joining nitrogen and hydrogen and for forming the ammonia. And that ammonia is used as a fertilizer. We all know that. But the credit goes to Haber. But Haber was the poison advisor of Hitler. And Haber rule is taught to you in toxicology. K is equal to C into T is Haber's rule. That Haber, who was born in Poland, Persia at that time, educated in Germany and then worked for Germany, and he was instrumental in creating these new war chemicals for Hitler. And later on in 1933, he died in Switzerland. He moved from Germany to Switzerland, and there in 1933 or so he died. But he was the person responsible for, we cannot forget, Haber, Friedrich Haber. Friedrich Haber worked, he was awarded Nobel Prize in 1918. He was in charge of the German poison program. So this is a brief time scale of the use of war chemicals by different countries. Now, if you come down to the various types of these war gases, what they are, you can classify them on the basis of the effects. That there are certain chemicals, they affect the nervous system. There are certain chemicals that affect the respiratory system. There are certain chemicals that affect the skin. There are certain chemicals that affect, they have got a cytotoxic action. So in this way we can classify them further, that these are the chemicals. Say for example, if we take the example of those chemicals which are affecting the nervous system, we find that cycloserine, we find serine, soman, tabun, VK, VR, some insecticides and some novic agents. They inactivate the enzyme acetylcholinesterase, and they are responsible for disturbing the neural transmission. Therefore, they are used in the form of vapors. They can kill the person from 2 to 18 hours. So this is then another one is the arsine that causes intravascular hemolysis. Arsenic se aati hai ye. Then there are some asphyxiation agents. They are nerve agents. Then there are some asphyxiation agents. Asphyxiation is caused by most of the arsenic compounds. Asphyxiation is suffocation. Then we have got the cyanogen chloride. We have got the hydrogen cyanide. They all are directly preventing cells from using oxygen. And then cells, they have got no other way to use the anaerobic mechanism. And if they fail to do that, they die. The death occurs. So they are deadly poisons because they affect the respiration. Then we have got the vesicular or blister agents. Sulfur mustard is a blister agent. Nitrogen mustard is again a blister agent, and then there is a levisite. I was talking to some in another lecture. British anti-levisite was discovered. Ball, a chelating agent, was discovered to fight against the levisite, and levisite was used as a war chemical, resulting into respiratory problems. Phosgene, again a chemical affecting the respiratory system. Then we have got chlorine. Chlorine, it looks very simple. Oh, chlorine, but chlorine can be used as a war chemical, and it has been used. Hydrogen chloride, then nitrogen oxides, then again phosgene. Similar mechanisms like blister agents, they express. Then we have got lacrimetric agents, those agents which cause lacrimation, and in that lacrimation we have got at the top the tear gas. They cause there was a photograph on the website, some website, that the British soldiers became blind because of these war chemicals. They were used by Germans and others, and the British soldiers, all of the troops, they became blind. So they causes a severe stinging in the eyes and temporary blindness. Then incapacitating agents, they are very much dangerous. They incapacitate means they are having a atropine-like inhibition of acetylcholine. And then we have got these agents are, I can tell you, agent 15. These are the agents. Then there are certain cytotoxic chemicals. They are ricin, they are abrine. And if we categorize these chemicals in another way, this is one way how the effects are caused. Another way is that they are defoliants, they are incendiary explosives, and of course, the biological warfare agents are the viruses. So there are blood agents also, which affects the blood. This is levisite, this is cyanogen chloride, this is hydrogen cyanide. Pulmonary agents, phosgene. Lacrimating agents, this is the tear gas, sarin, soman. These are the tear gases. In addition to that, if we just summarize, we can we find that in 1914 it was the time of chlorine. In 1918 it was the time of levisite. In 1920s and 30s it was G series of agents. And from 1940s to 60s it was V series of agents. So how they are disseminated? Some of the gases are disseminated into the air or into the wind. The others are disseminated in the form of chemical shells. Others are disseminated through aerodynamic mechanisms. The planes, they download the gas cylinders. Then the aircraft bombs are used. Missile warheads are used. And sometimes the binary ammunitions are used. So there was again a convention by the United Nations, and that convention, again, next to Geneva Convention, it was held sometimes in 1999 to ban the use of these war chemicals. You see, India had a stockpile of war chemicals, and India declared it. And after declaring that India has got this stockpile of chemicals, India also told United Nations that now we have destroyed these chemicals. When Iraq and Iran war was held, the United Nations team went to Iran and suggested Iran, you finish these war chemicals. When Syria was, Syria was is still going on. 7 years are over. More than 350,000 people have already died in that war, and there is no scope for ending. As we see it, that there seems to be no end to this war. They were using the chemicals, and the United Nations advised them there is some treaty to deal with the use of these chemical and biological warfare agents, and that treaty forbids the use of these biological as well as the chemical warfare agents against the society. So this is in just a brief idea about the chemical warfare agents, what is the contribution of Haber, and how these wars have been fought earlier, right from earlier than the World War I and then World War II. We shall proceed with the detailed toxicological studies on each one of them. And thank you for watching. Keep on watching. I'll be giving you something new always. Have a good time. Bye.